Hi everyone, today we are going to learn about how to deduce electronic configuration. This question is asking you to determine the electronic configuration of manganese 2+ ion. To answer this question, you should recall that there are 3 rules to fill the electrons for each element. Firstly, electrons are filled into the orbitals of the lowest energy. You should be aware that empty 3d orbitals are always higher energy than 4s orbital. That's why we should fill the electrons into 4s orbitals first, before 3d orbitals. Next, if more than one orbital in the sublevel is available, electrons are placed into different orbitals with parallel spins in order to minimize electronic repulsion. That means if we have 3 electrons in p orbitals, we should fill them into different p orbitals first before pairing them up. The 3 electrons have to be arranged in parallel spins, which means the electron drawn should point in the same direction. The third rule is saying that 2 electrons in the same orbital have to spin in the opposite direction. Therefore, 2 drawn arrows within the same box should be pointing in the opposite direction. To solve the problem, in step 1, we have to find the electronic configuration of manganese atom. The number of electrons of manganese equals to 25, so we can fill the electrons according to the 3 rules mentioned before. When we fill the 19th electron, remember that 4s orbital has lower energy than 3d orbital, so we can fill the electrons into 4s orbital first. Eventually, the electronic configuration of manganese atom is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5, or we can simplify it using the noble gas configuration, Ar 4s2 3d5. Next, to find the electronic configuration of manganese 2+ ion, which means the manganese atom loses 2 electrons, we have to know that the filled 3d orbital will push the energy level of 4s orbital higher than itself. So, electrons will be lost from 4s orbitals first. This is true for all transition metal ions. Therefore, the electronic configuration of manganese 2+ ion is Ar 3d5. You should bear in mind that there are 2 elements that do not follow the rules that we have to memorize for IB chemistry. The first one is chromium. If we follow the rules mentioned before, we would get Ar 4s2 3d4. However, this is not the correct configuration of chromium. Instead, 1 electron from the 4s orbital moves to the 3d orbital such that all 4s and 3d orbitals are half-filled. This causes chromium to gain extra stability by minimizing electronic repulsion. Therefore, the electronic configuration for chromium should be Ar 4s1 3d5. The second element is copper. If we follow the rules mentioned before, we would get Ar 4s2 3d9. Similar to chromium, we can move 1 4s electron to 3d orbitals such that the 4s orbital is half-filled while all the 3d orbitals are fully filled. This also makes the copper atom more stable due to it being fully filled. Therefore, the electron configuration for copper should be Ar 4s1 3d10. Electronic configuration deduction is an essential fundamental skill for IB chemistry students. Hope this video helps you to understand more about the principle behind electronic configuration deduction. See ya!